Let us understand what is pulse modulation. Now, if we see in a broad way, the pulse modulation is also divided into two broad categories. One is the pulse analog modulation, another we can say that it is the pulse digital modulation. The pulse analog modulation and the pulse digital modulation, in pulse digital modulation is basically the pulse code modulation, where we convert the sampled signals into the stream of bits, or we can say we encode that sample into 8 bits or 10 bits, it depends. But the pulse analog modulation is same as the analog modulation which we know, that is amplitude modulation, the frequency modulation and the phase modulation. So in all these three modulation, amplitude modulation, frequency modulation, then the phase modulation, the carrier signal is of analog sine wave. Usually we use as a sine wave as a carrier frequency, carrier signal. Now the same way, when we talk about the pulse analog modulation, so we all know that pulse is again a signal which is of analog type. It has three different important parameters. One is its amplitude, another is, instead of its width, definitely it is having the frequency, but it also has a width. So the another important parameter is the width of the pulse, and third is its position with respect to the clock. So we know that in amplitude modulation or in frequency modulation or in the phase modulation, by the instantaneous value of modulating signal, we change any one of these parameters, either amplitude keeping frequency and phase constant, or frequency keeping amplitude and phase constant, or phase keeping amplitude and frequency constant. If we change any one particular parameter by the instantaneous value of modulating signal, then the modulated output which we get, it becomes the respective modulation what we are getting. So for example, if we change the amplitude of sine wave by the instantaneous value of modulating signal, if we change the amplitude of carrier, then it becomes the amplitude modulation. If we change the frequency of carrier by the instantaneous value of modulating signal, then it becomes the frequency modulation. If we change the phase of the signal by the instantaneous value of modulating signal, phase of the carrier, so then it becomes the phase modulation. So now we know that in pulse we have three parameters: pulse amplitude, pulse width and the pulse position with respect to clock. So any one of these parameters, by keeping rest of the two parameters constant, if we change with the instantaneous value of the modulating signal, then it will become that particular type of pulse modulation. So if by the instantaneous value of modulating signal, if we change the amplitude of pulse, then it becomes the pulse amplitude modulation. If we change the width of the pulse by the instantaneous value of modulating signal, then it becomes the pulse width modulation. And if the position of pulse with respect to clock changes with the change in instantaneous value of modulating signal, then it becomes the pulse position modulation. So these are three major types of pulse analog modulation: pulse amplitude modulation, pulse width modulation and pulse position modulation. Let's learn this fantastically through a Simtel, which is a software for teaching and learning, or people call it simplified teaching and learning, from Scientech. So now we can see that for any modulation technique you have two kind of signal. One is the carrier signal and another is the modulating signal. So by default in pulse modulations, the pulse analog modulation, the default, the carrier signal is pulse. So we can see that this is the pulse of constant amplitude. So this is a pulse of constant amplitude, and this is our carrier signal. This is a modulator block. So basically I'm just adding this. So this is a pulse amplitude modulator block. This is my modulating signal, so I can set its frequency by this, and I can change its instantaneous value. I can change its amplitude by this knob, or by this basically drop window. So now let's see that what is the modulating signal is. So this is my modulating signal. So I switch it on and I switch it to, say for example, to the 1 kilohertz. So right now it is the 1 kilohertz is the modulating signal what we are having. But now the amplitude right now 0, so there is no modulating signal showing over here, and that is the reason there is no amplitude modulation has yet takes place, because there is no modulating signal. The moment I will add this modulating signal, then by the instantaneous value of this modulating signal, the amplitude of these pulses will change, and we can see that this is how a pulse amplitude modulated signal output will look like. So let's add that. So I'm adding this modulating signal. You can see that I'm adding this modulating signal. You can see that the amplitude of the pulse is changing. Now here amplitude of pulse is high, here the amplitude of pulse is low, here again it is increasing into this direction. So this is how the amplitude of the pulse is changing with the help of the instantaneous value of modulating signal, and that is how we call it as a pulse amplitude modulation. So this is a pulse amplitude modulation. Now let's go for the pulse width modulation. So right now you can see that these are the pulses of constant width. There is no modulating signal is been added into the pulse width modulator circuit. So now let's set the modulating signal's frequency as a 1 kilohertz. So set it at a 1 kilohertz. Now the moment we will add this modulating signal, then by the instantaneous value of modulating signal, the width of these different pulses will change, and that is nothing but that will be the pulse width modulation. So let's add this modulating signal into the pulse width modulation. So I am adding this, we are adding this. You can see that now the width of each and every pulse is different, and this change in width of the pulse is because of the instantaneous value of modulating signal, and this is how the pulse width modulation. If I remove this modulating signal, again I will get a constant width pulses. If I add the modulating signal, you can see that the width of the pulses changes, and this is how the pulse width modulation is. Now next is the pulse position modulation. Now you can see that, see for example, this is a pulse position modulation. These are the pulses and this is the clock. The clock is marked with the help of these green spots over here. Right now we can see that each pulse is matching with the clock edge. So each pulse position is with respect to clock is that it is matching the clock. Now when we will add this modulating signal to this pulse position modulator, we can see that according to the instantaneous value of modulating signal, the position of these pulses with respect to this clock will change, and that is nothing but that is the pulse position modulation. So let me add this modulating signal here. Now you can see that position of pulses is changing. Position of pulses is changing with respect to clock. Again you can see that I am adding. You can see that position of each pulse with respect to clock had changed. Each has changed. Even again let me add this. You can see that now this is far away from this particular clock. This is compared to this is close. This is on the back side of the earlier this clock. So this is how the position of these pulses with respect to clock changes according to the instantaneous value of modulating signal, and this is how we call it as a pulse position modulation. So there are three types of analog pulse modulation broadly. One is the pulse amplitude modulation, pulse width modulation, and the pulse position modulation.